Recursive prompting, a technique where the output of one prompt is used as the input for another, creating a chain of prompts that build upon each other. Embedding space manipulation in prompts. This involves tweaking the embedded representations, vector space, within the language model through prompts, aiming to steer the model's responses more precisely. Cross-model prompting. Utilizing prompts that are designed to be effective across different models, focusing on generalizability and adaptability of the prompt structure. Meta-learning in prompt design, creating prompts that enable the model to learn how to learn from the given input, enhancing its ability to adapt to new tasks with minimal examples. Dynamic prompt evolution, a method where prompts are continually adjusted and evolved based on real-time feedback or the AI's performance, making the interaction more adaptive. Prompt chaining for complex tasks. Linking multiple prompts in a sequence to handle complex tasks that require multiple steps of reasoning or generation. Imagine a scenario where a user interacts with an AI model for a complex task. The AI is initially given a generic prompt that doesn't yield the desired output. Here, dynamic prompt evolution comes into play. The AI's response is evaluated, and based on this evaluation, the next prompt is adjusted. This could involve making it more specific, changing the phrasing, or even incorporating clues from the model's previous response. This process continues in a loop, with each prompt evolving based on the AI's performance and real-time feedback. The result? A more adaptive interaction that continually improves over time, and an AI model that becomes progressively better at understanding and responding to the user's needs. This scene will illustrate the practical application of dynamic prompt evolution, with a walkthrough of this recursive process, and examples of how prompts can be adjusted and evolved. In this scene, we delve into the concept of multi-objective prompt optimization. As we've seen in earlier scenes, crafting a prompt is an art in itself, but what happens when we have multiple objectives to fulfill? Does it make the process more complex? Yes, but it also opens up a world of possibilities. Imagine a scenario where you want your AI model to not just provide accurate information, but also to do it creatively and ensure the output is relevant to the user's context. This is where multi-objective prompt optimization comes into play. Here, the aim is to craft prompts that balance different objectives, in this case, accuracy, creativity, and relevance. This can involve using a variety of techniques from hyperparameter tuning to probabilistic prompting, and even AI-assisted prompt crafting. The process starts with defining the objectives clearly, then designing the initial prompt with these objectives in mind. The AI's response is then evaluated against these objectives. Based on this evaluation, the next prompt is adjusted to better meet the objectives. For instance, if the first response is accurate but lacks creativity, the next prompt could encourage more creative thinking. If the response is creative but not relevant, the next prompt could include more context-specific cues. This iterative process continues, with the prompts evolving in real time, until a balance is achieved between all the objectives. The end result? An AI model that doesn't just spit out accurate information, but does so in a creative, contextually relevant way that truly engages the user. This scene will provide practical examples of how multi-objective prompt optimization can be implemented, demonstrating the potential of this approach to create more adaptive, engaging, and effective AI interactions. In this scene, we'll be exploring an intriguing concept: AI-assisted prompt crafting. As we've already seen, crafting the perfect prompt is both an art and a science. But what if we could leverage the power of AI itself to make this process more efficient and effective? Imagine a scenario where the AI model is not just the responder, but also plays a role in crafting the prompts. It sounds like science fiction, but with advancements in machine learning and AI, it's a rapidly emerging reality. This concept is known as AI-assisted prompt crafting. Here's how it works. The AI model is initially fed with a batch of prompts. It then generates responses for these prompts. Based on the responses, the AI model identifies patterns and learns to understand what makes a good prompt. Using this knowledge, the AI model then generates or optimizes the next batch of prompts. This can be particularly useful in areas where human expertise is limited, or when dealing with highly complex or niche topics. But how do we ensure the AI-generated prompts are effective? This is where the principles of multi-objective prompt optimization come into play. The AI-generated prompts are evaluated against multiple objectives, such as accuracy, creativity, and relevance. If the prompts meet these objectives, they are used for the next iteration. If not, the AI model learns from this and adjusts the future prompts accordingly. This scene will provide real-world examples of AI-assisted prompt crafting in action and demonstrate how this approach can lead to more effective prompts, better AI responses, and ultimately, more engaging and productive AI interactions. Stay tuned as we delve deeper into the fascinating world of AI-assisted prompt crafting. In this scene, we will delve into the fascinating world of causal prompt engineering. This innovative approach to prompting doesn't just look to elicit responses from AI, but also aims to understand or influence the causal relationships within the model's outputs. But how does it work? Let's break it down. Causal prompt engineering begins with the crafting of a prompt that is designed to probe the AI model's understanding of cause-effect relationships. This could be a question about why a certain event happens, or a hypothetical scenario that changes an event's outcome. The AI's response to this prompt provides insight into its understanding of causality, but it's not just about interpreting the AI's response. The real magic of causal prompt engineering lies in its ability to influence the AI model's outputs. By carefully designing our prompts, we can guide the AI model to consider certain causal relationships, or to emphasize specific cause-effect chains in its responses. This technique allows us to not only get more insightful responses from our AI model, but also to shape its understanding and outputs in ways that align with our objectives. Whether we're trying to teach an AI model about a new topic, guide it to make more informed predictions, or simply to explore its understanding of complex causal relationships, causal prompt engineering can be an incredibly powerful tool. Stay tuned as we explore real-world examples of causal prompt engineering in action and reveal how this technique can take your AI interactions to the next level. In this new scene, we will explore interactive evolutionary prompting, a user-centric approach that leverages feedback to refine and evolve prompts over time. This method is akin to evolutionary algorithms in computer science, where solutions evolve and improve through iterations. Interactive evolutionary prompting starts with a basic prompt. When the AI responds, the user provides feedback, which could be a simple rating, a comment, or a more complex evaluation. This feedback is then used to adjust the prompt, creating a new, improved version. This process is repeated, with each iteration refining the prompt and making it more effective. The beauty of interactive evolutionary prompting lies in its adaptability. By incorporating user feedback, it allows the prompts to evolve and adapt to specific needs and contexts. This method can be particularly useful in scenarios where user preferences are diverse and unpredictable, or when the task at hand involves a high degree of subjectivity. In the end, interactive evolutionary prompting is about creating a dialogue between the user and the AI, a dialogue that guides the AI towards more helpful, relevant, and personalized responses. Stay tuned as we dive deeper into this innovative method, exploring its potential and showcasing its real-world applications. In this section, we delve into the realm of context-aware prompt personalization. This approach takes into account the user's preferences, history, or situational factors to tailor prompts, ensuring a more personalized and relevant AI experience. Think of it as a tailor-made suit designed to fit the unique shape and style of each individual. In the case of AI, the prompts are the suit, and the user's context is the unique shape and style. To start, the AI system gathers information about the user's preferences and history. This could be through direct user input or by analyzing previous interactions. Once it has a good understanding of the user's context, it uses this information to customize the prompts. The aim is to create prompts that not only elicit accurate responses from the AI, but also resonate with the user on a deeper, more personal level. For example, if a user often asks queries related to cooking, the AI might personalize its prompts to incorporate culinary terms or references. Or, if the user is a professional musician, the AI might tailor its prompts to reflect a deeper understanding of music theory and practice. This way, the AI not only answers the user's questions accurately, but also does so in a way that feels more familiar and relevant to the user. In essence, context-aware prompt personalization is about making AI more user-friendly. It's about ensuring that the AI understands not just what the user is asking, but who the user is and what they care about. This approach can significantly enhance the user experience, making AI interactions feel more engaging, intuitive, and personally meaningful. Stay tuned as we explore how this exciting approach is being applied in real-world scenarios. In our next exploration, we delve into neurosymbolic prompting, a unique approach that combines symbolic AI techniques with neural network-based prompt engineering. Imagine creating a prompt that not only leverages the power of deep learning to understand complex patterns, but also incorporates explicit knowledge representation from symbolic AI. This is the essence of neurosymbolic prompting. Symbolic AI, with its rule-based systems, provides a clear, understandable structure. It's like a city map, guiding the AI through the complexity of tasks, where each rule is a signpost leading to specific actions or results. On the other hand, neural networks, the backbone of deep learning, adapt and learn from data, much like a seasoned explorer navigating through the city, learning shortcuts and hidden treasures over time. When we merge these two approaches, we get prompts that are not only adaptable and efficient, but also transparent and interpretable. The neural component helps the AI to adapt to new situations and learn from past experiences, while the symbolic component ensures that the AI's actions can be traced and understood. This fusion allows us to create prompts that are dynamic, yet understandable, flexible, yet reliable. Consider a scenario where a user is interacting with an AI system to diagnose a technical issue. A neurosymbolic prompt might leverage the neural network's ability to understand the user's natural language description of the problem, while the symbolic AI component could provide a structured troubleshooting guide, leading the user through a series of diagnostic steps. In essence, neurosymbolic prompting is about creating a synergy between two powerful AI approaches. It's about crafting prompts that are both intelligent and interpretable, capable of learning from experience, while also providing a clear, understandable structure. This is truly an exciting frontier in the world of AI prompt engineering. Stay tuned as we further delve into its potential applications and benefits. As we enter the realm of prompt debugging techniques, we get a chance to delve into the methods used to analyze and improve the prompts. It's like being a detective on the trail of understanding why an AI generated a particular response. This process starts with analyzing the prompt, examining its structure, content, and contextual cues. Just like debugging a software program, we want to identify any potential issues that could be leading to unexpected or undesired responses. For example, a prompt might be too vague or too specific, leading the AI down an undesired path. Or perhaps the prompt is not aligned with the user's intent, resulting in a misunderstanding. It's also crucial to consider the AI's training data and its inherent biases, as these can heavily influence the generated responses. To illustrate, imagine a prompt designed to generate a story about a day at the beach. If the AI's responses are consistently off-topic or nonsensical, we might need to debug the prompt. Is the prompt clear and specific enough? Is the AI misunderstanding the user's intent? Are there biases in the AI's training data that are influencing the responses? By identifying and addressing these issues, we can improve the quality and relevance of the AI's responses. Furthermore, debugging can also involve experimenting with different prompt strategies, adjusting the parameters, or even retraining the AI with more relevant data. The goal is to create a feedback loop where the AI's responses are continually monitored and improved, based on user feedback and analysis. So, in essence, prompt debugging techniques are about understanding, analyzing, and refining the prompts to ensure they elicit the desired responses from the AI. It's a vital part of the prompt engineering process, ensuring that our prompts are as effective and user-friendly as possible. Stay tuned as we delve further into this fascinating aspect of AI prompt engineering. As we venture deeper into the world of advanced prompt engineering, we encounter an intriguing concept: latent variable prompting. This technique is akin to being an orchestra conductor, guiding a symphony of unseen variables to create a harmonious output. Latent variables, the silent actors of AI, are internal variables within generative models that control specific aspects of the output. They're like the strings of a puppet, controlling the AI's responses from behind the scenes. Through latent variable prompting, we can manipulate these variables to control specific aspects of the AI's generated output, opening a whole new world of possibilities for prompt engineering. Imagine being able to adjust the tone, style, or complexity of the AI's responses just by tweaking the latent variables. or being able to guide the AI's creative process, influencing the direction and content of its generated stories, articles, or scripts. This technique is not just about crafting prompts. It's about understanding and manipulating the underlying mechanisms of the AI, turning the invisible controls to achieve the desired output. However, latent variable prompting is not a tool to be used lightly. It requires a deep understanding of the AI's architecture and the interplay of latent variables. It also requires careful calibration, as changing one variable can have a ripple effect, influencing other variables and aspects of the output. But with careful use and understanding, latent variable prompting can be a powerful tool in the scriptwriter's arsenal, enabling us to shape and guide the AI's responses with unprecedented precision and control. So, buckle up as we dive into this exciting frontier of prompt engineering, where we learn to master the invisible controls of AI. As we traverse the fascinating landscape of AI-assisted prompt crafting, we stumble upon a technique that marries the raw power of AI with the structured beauty of databases. Welcome to the world of knowledge-infused prompting. This technique involves integrating structured knowledge sources, like databases or knowledge graphs, into the prompt design. This fusion of structured and unstructured data enhances the model's contextual understanding and response accuracy. Imagine a script that not only responds to your prompts, but does so with an enriched understanding of the world, made possible by integrating a vast knowledge database into its responses. For instance, a script about historical events could include facts sourced from a historical database, or a script about a popular movie could incorporate details from a movie database. Knowledge-infused prompting is not just about improving the AI's responses. It's about creating prompts that allow the AI to leverage its vast knowledge base, resulting in richer, more contextually aware responses. This method can be particularly useful when crafting scripts that require a deep understanding of specific topics or fields. But as with all powerful tools, knowledge-infused prompting requires careful handling. The integration of structured knowledge sources needs to be done judiciously, ensuring that the AI's responses remain coherent and relevant. Overloading the AI with too much structured data can lead to verbose or off-topic responses. However, when done correctly, knowledge-infused prompting can greatly enhance the quality and richness of the AI's generated scripts. So, armed with this new technique, let's continue our journey into the exciting world of AI-assisted prompt crafting, where creativity meets technology, and the possibilities are limited only by our imagination. Hyperparameter. Optimization in prompting, fine-tuning the parameters of the prompting process, such as the length, complexity, or specificity of prompts, to optimize the AI's performance. Conditional prompting for contextual relevance, designing prompts that change dynamically based on the context or the specific conditions of the task at hand. Probabilistic prompting, incorporating elements of probability and uncertainty into prompts, allowing for more nuanced and varied responses from the AI. Prompt ensembling, combining multiple prompts or prompt strategies to create a more robust and effective input, similar to ensemble methods in machine learning. Multi-objective prompt optimization, crafting prompts that aim to fulfill multiple objectives simultaneously, balancing various aspects like accuracy, creativity, or relevance. Prompt-based model, distillation, simplifying complex AI models into more efficient versions by using carefully designed prompts to retain key functionalities. AI-assisted prompt crafting, using AI itself to generate or optimize prompts, leveraging the model's understanding to create more effective inputs. Causal prompt engineering, designing prompts that not only elicit responses, but also aim to understand or influence the causal relationships within the model's outputs. Interactive evolutionary prompting, a technique where user feedback is used to iteratively evolve and refine prompts, akin to evolutionary algorithms. Context-aware prompt, personalization, tailoring prompts to individual users or specific scenarios, taking into account user preferences, history, or situational factors.